Hi, this is Anna McCullum. Thanks for attending this session on smarter ways to manage incidents with event compression and dynamic runbooks. We're going to start with an overview of our solution for managing events. Then we'll provide a recap on how event compression works before getting into details of our recent enhancements in this area. We're also going to discuss new features we've added in dynamic runbooks. As IT environments grow over time, the amount and variety of events correspondingly increase. It becomes even more important to implement solutions to help you manage these events. Our solution is threefold. First, we recommend that you create incidents for important and actionable events. You can open tickets and send notifications to your ITOps teams for these incidents. When creating incidents, you should enable the option to use event compression policies. These policies correlate related events and compress them into a single incident, so you have a reduced set of incidents to work on. Finally, you should create dynamic runbooks to capture your team's best practice procedures for triaging and resolving incidents. These runbooks are immediately accessible to your IT ops teams in context of incidents. These features have been made available in prior Enterprise Manager releases. In this session, we'll go over enhancements we've made in these areas. Let's first do a review of event compression policies. Event compression policies state the condition in which multiple correlated events are grouped together in a single incident. Oracle provides a library of event compression policies that you can use. These policies work with your event rules in your incident rule sets, as long as you enable the option to use event compression policies. Let's review how these policies work. For example, one out-of-box policy correlates and groups or compresses target down events from all WebLogic servers that are part of the same WebLogic cluster. Let's say you have an incident rule set with a rule to create an incident for all target down events for your production group, which includes your WebLogic servers. In your rule, make sure you also choose the option to use event compression policies. If the WebLogic servers go down, each of these will generate a target down event. Before creating an incident, EM will first check to see if there's a matching event compression policy. If found, it will correlate and compress the events into one incident. So you'll end up with one incident containing 3 events instead of 3 incidents containing 1 event each. What if there are additional ways that I want to compress events and I do not see any out-of-box policies for this? You can create your own event compression policies. Here's how you do it. It basically involves specifying the types of events you want to compress and the criteria by which you want to group or compress them. Let's look at the individual fields. First, specify a meaningful name for your policy. In our example, we want a policy to compress availability events for coherence targets. Then we identify the events you want to include. We specify the target availability event type for the coherence targets, and we want events across all severities. We only want to include events that have triggered within 60 minutes of each other. Then we specify that we want to group or compress together events that have the same parent coherent cluster. Finally, when an incident is raised, we can choose a custom message for the incident or keep the default. For now, let's keep the default message. After we've created the policy, the next step is to test the policy using the event compression analysis report, which I'll discuss in a few minutes. Once testing is complete, if we are happy with the results, we can publish the policy, which changes its status from draft to published. Then the last step is to enable the policy, which makes it available for use with incident rule sets. To test our new policy, which is still in draft status, or to check the general effectiveness of all other policies against our specific events, we can use Event Compression Analysis tool. Event compression analysis basically simulates the creation of incidents with event compression policies enabled against your own events. So the results that you will see are meaningful and specific to your environment. To run the analysis, you give the analysis report a name, specify a group of targets whose events you want analyzed, and also a time period for when the events occurred. If you had a recent event storm, you could use the analysis tool on that time period when the event storm occurred to see if event compression would have helped reduce the incidents triggered during that period. Notice also there's an option to include draft policy. This means your user-defined compression policy will also be included in the simulation and hence provides the best way to test and validate your event compression policy. Here are the results of the event compression analysis. It tells us that it analyzed 52 events, and without event compression policies, 52 incidents would have been created. However, with event compression policies, only 16 incidents would have been created, which is 69% fewer incidents. It also tells us the average event compression ratio is about 3 events per incident. I also see this summary in graphical form in the charts below. Notice a smaller orange bar of incidents with compressed events compared with the taller blue line of incidents without compression. I can click on the bar chart to get further details. Here we see a mapping of events between incidents without compression on the left to incidents with compression on the right. For example, if we look at this mapping more closely, we see that many events that were individually in their own incidents, as indicated by the individual blue lines, each blue line representing an incident, are now grouped or compressed into a single incident on the right, represented by the orange line. I could also further drill down to identify these individual events that were compressed together. This compression analysis included the policy I just created. I'm happy with the result, so I can publish and enable my policy for general use. In addition to assessing the general effectiveness of your current compression policies, you can use this analysis to identify events that are not compressed into any incident, and therefore a good candidate for additional event compression policies. Now let's talk about Dynamic Runbooks. Dynamic Runbooks allows subject matter experts to capture their best practice procedures into executable steps in Enterprise Manager. Let's review how Dynamic Runbooks work. To create a Dynamic Runbook, your subject matter expert, say your senior DBA, would create a runbook based on an incident. This runbook is called a runbook draft, and it will automatically include the incident context that includes the metric, timestamp of the event, target on which the event occurred, etc. He then creates steps to triage and resolve the incident. As he is developing the runbook, he can run and test each step against the target. Once he has completed and tested the steps, he can publish the runbook. ITOps teams have access to runbooks in Incident Manager. In Incident Manager, they will see the appropriate set of runbooks that are applicable to that incident. He can start a runbook session, choose a runbook, and execute each step in the runbook. If credentials are needed, he may be asked to specify these. Once he has completed the runbook and hopefully has resolved the incident, he can mark the runbook session as done. Now let's drill down into the different types of actions that can be done in a runbook. Actions are specified by runbook steps. Here we show the different types of runbook steps. The recent enhancements to the steps are highlighted in bold. The note step is used to provide instructions. There are often steps that are not executed in code, such as check with the apps team to see if their logs can be deleted. It is useful to include these types of steps as part of the runbook so that it is complete. You can use Markdown syntax to better format your instructions. We've enhanced the note step to include links to Moss notes if you want to reference some additional instructions or background information from Oracle support or links to any site. Target SQL allows you to run queries, DML, or DDL against a target database. It uses name credentials to access the database. These name credentials can be configured to be integrated with PAM providers, that is, privileged access management providers such as CyberArk. Repository SQL allows you to run queries against the repository views. The metric data step allows you to show metric data in the chart. By default, this chart will also indicate when the event has occurred. We're also introducing a new OS command that can be used to run a synchronous OS command or script against a host target or the host of the target, such as the host of a database if the incident was against a database. Name credentials are required for running the OS command, and they can be integrated with PAM providers. Here is how you can use the OS command step. Here we see the target of the runbook is a database, so this OS command will run on the host of the database. When creating an OS command step, first specify the name credentials that will be used. If you want the runbook users to specify his credentials, then in the runbook step, first create a runbook variable that will contain the credential value, then specify the variable in the name credential field. Next, specify if the step is running a command or a script. Here we choose a script. You can enter your script directly in this UI, or if the script is already located on your host, you can specify the path to your script. Notice your script can use runbook variables whose values can be populated during the runbook session by the user. After entering the script, you can click on the Run button to verify your script is working correctly. After I've created my runbook, how do I designate that specific runbook is what I want my users to use when the incident has occurred? To designate a specific runbook that should be used for a specific type of incident, you do this via event rules. In the event rule that creates an incident, there is a new runbook setup section. Here you can specify the runbook that you would like your teams to use when the incident identified in the event rule occurs. After you've done this association, if the incident occurs, it will automatically be shown in Incident Manager, which has an annotation that it has been recommended by the incident rule. This will remove the burden on IT teams to determine which runbook to use when triaging incidents. As your colleagues are working on resolving the incident in the runbook session, is there a way for others to collaborate on this? Yes, this is possible using the comments feature. First, the runbook session owner, that is, the user working on the runbook, can jot down notes in the comment section as they work through the runbook steps. Other members of their team who have access to the incident can view the runbook session, see the triage output thus far, and provide their input, making it easy to collaborate since all comments are provided in context of the runbook. Finally, when the runbook session has completed and the incident has been resolved, any postmortem notes for the incident can also be added using comments, thus making it convenient for users to refer to the past incident, understand what happened, and any lessons learned should the incident occur again. Now let's see how runbooks can be used. In our example, we have created a runbook to triage and resolve an FRA Fast Recovery Area Full incident. We start off with an incident indicating that the FRA is full. In Incident Manager, we can start a runbook session and use the recommended FRA runbook. In our Runbook session, we look at step 1, which is a review of the prerequisites for this runbook. It tells us to make sure we have access to the named credentials for the database and also for the host of the database. We execute step 2, which shows us a trend of the FRA usage over time. We see when the event was triggered and also notice an increasing FRA usage. We click on the gear icon for step 3, which prompts us to enter the database name credentials for the database. Now step 3 has a play button, which we can click on to execute the step. It shows us the current size for the FRA. It also asks that I verify that the FRA size is set to at least 350 gigs. I notice the FRA size is 200 gigs, which is lower than the recommended 350 gigs. I also notice that I can click on the What's FRA if I need some reminders about what FRA is used for. Before increasing the FRA size, I execute step 4 to identify the file system used by the FRA. On step 5, there's another gear icon that I click on. When I do so, I am prompted to specify the host credential for the host of the database and also the file system of the FRA, which I obtained in step 4. Now I can execute step 5, which tells me the space available on the FRA file system. It also tells me to ensure that there's enough space on this file system so that the next step can increase the FRA size. Clicking on this step will update the FRA size to be 350 gigabytes. I executed this step successfully. Executing step 7 will verify that the FRA is now sized correctly to 350 gigabytes. In addition to creating your own runbooks, we'll be providing a library of built-in dynamic runbooks that you can use. We start off by providing these two runbooks. The first is a runbook to help triage and resolve errors in the database table space used metric. The second is a runbook to triage and resolve issues when you have a lot of agent backoff requests occurring in EM. Details of this runbook will be covered in the session Improve Operational Efficiency Using New EM Diagnostics Runbook. We've covered enhancements in event compression that help you reduce overall incident volume by compressing related events into single incidents. We continue to build on our dynamic runbook capabilities and also provide built-in runbooks to help your IT teams have immediate access to expertise to triage and resolve these incidents. Collectively, we hope these new features help you manage your incidents even more effectively. For additional information, here are links to resources with more details on the features we discussed today. Thanks for joining our session. Here are links to Enterprise Manager website, videos, and other resources.